Hey guys, welcome back to my channel. I am AttiDude back in another video, and in today's video we're gonna be learning about interfaces in C#. Interface has been one of the most important feature that C# provides to all the users, to all the developers, whether you are in game dev field or in software development field. You use interfaces every now and then, and interfaces help to keep the code cleaner and more readable. Even you can reuse the code to achieve easiness and performance easily. So, if you haven't liked or subscribed my channel yet, do it now. I'll provide more content like this. Without any further ado, let's get learning interfaces. So this was the script that we edited in our last video. I'm gonna delete literally everything except of the console.readline in the main function. Even this. And first of all, we're gonna create a class named player. Okay, so we have our class. Let's implement a damage function. Or take damage. Okay, so we have our take damage function. So we're now gonna create an interface. First of all, let's understand why do we need interface. For example, we have our player. Okay, player can take damage. Let's create a new property. This is gonna be of type integer. Public int, and I'm gonna name this health. We can just have simple get and set auto property, and inside of this we can write health minus equals to damage. Okay, we're now gonna collapse this function, and let's understand why do we need interfaces. We have this function. Okay, but if we were to implement the same kind of mechanics in 1,000 different types of objects, like we have some sort of tower-based strategy game, like tower defense game, like that. If you ever played Alien Shooter TD for mobile and Play Store, then you may know, or not that game, any sort of tower defense game. If you have ever played, then you may know that you have towers. Enemies come in, they shoot the towers, you need to shoot the enemies, you somehow need to survive the wave. Okay. Enemies can also be of 1,000 different types. Like you have for example, if you have a sci-fi based game, then you have a smaller one enemy which is very weak, then a very high damage, very high AI performance alien enemy which is really hard to kill. All of them actually have an interface called damageable. It's not like it has to be called damageable. You can call that to any name, but the logic will remain the same. You have 1,000 different objects which take damage, like you have a crate, on which if you shoot bullets, it will take damage. Its health will be reduced. if you have a tower on which if you shoot it takes damage, the health reduces. If you ever played Minecraft, then you may know that you break every single block in survival mode. It takes a lot of time for some blocks, and almost instantly some blocks break. So what actually is that? All of them have different scripts. Player has different script. A crate or maybe a box may have a different script. Enemy will, of course, gonna have its AI script. And if you talk about block in Minecraft, they all have different scripts. But one thing that they do have is a function, an interface which acts on them. Like, if we use an interface, it will force us to insert all of the things inside of an interface, all the members of an interface to be implemented in that class or struct. So far so good, and we can even access those blocks or those scripts as the name of our interface. Let's create an interface. First of all, to know the practical, I'm gonna name this damageable. Or maybe take damage interface. I think the damageable was the correct name. Naming actually doesn't matter here. You need to be very accurate with the name so that you just understand what it tries to say. First of all, we write the access modifier of the interface, which in our case is going to be public, and then we write the keyword called interface. Leave a space, and then we define the name of the interface. I'm going to name this damageable, but it's always a good practice to have I in front of damageable, because if you just press Alt Enter, you see fix name violation I damageable. That happens because it's generally a good practice to name interfaces with I in front of them, and capital I as the first letter, so that we know that it is an interface and it is not a class or a struct, so that we don't get confused. It's just basically this for the interface. We have defined our interface, but we still need something. I'm gonna copy this, paste this here, and you see it's all. The interface is actually done at this point of time. We need to implement this interface in our player class, in our function. Okay, we have the I damageable, and by default these are set to public and abstract, and if you're using C# 8.0 or later, then you can have a default implementation for the body. Properties and events can be defined inside of an interface, but fields and everything else cannot be defined inside of an interface. And once we have these interfaces, interface done, this interface, then we can go to player or any class or struct that you inherit the interface from, and you need to make sure that you have all the members of the damageable or the interface that you make implemented in the class or struct. For example, we have in our case is player. You need to have each and every member of damageable to be implemented in our player class. So we have that. Okay. And we have our interface. It's almost done. Let's create a new function. And I'm gonna name this okay, let's not create a new function, but actually call that function from somewhere. Like, you can make an interface of damageable, and I'm gonna name this player equals to new player. And you see that we can create damageable from player. Why? Why is that so? Why cannot we create damageable? Because interface or an abstract class cannot have a constructor, or they cannot be instantiated, they cannot be defined. We can only access them if any class inherits from them, and we can take their data. So we now have our player, and we can just go ahead and call player player dot take damage. And you see, it is like there's no argument that corresponds to that. Don't worry about that. Just write 10 in front, because parameters don't match. And at this point of time, we don't know what the health would be. So first of all, we can write player dot health equals to 100. And in here, we can write console.writeLine player.health. Let's run. 90, yes. This indeed works. But you'd say, why are you using damageable, the interface, instead of using as a player? Wait, my friend. When you have 1,000 different objects in the scene that can take damage, you're gonna reference each and every of those. Like, if we were to use Unity and you have the on trigger enter function, then every time we hit, we create a new player. Okay, we first of all check if it's null. If it's not, then we call. If it's null, let it be. And same for enemy, same for crate. This thing is not at all performant, and it's even hard to read, hard to understand. In general, it's not at all a good practice to do that. And the alternate solution to that we have is interface. If we create an damageable interface and assign that to each and every object that we need to take damage, then we can easily do that. We can just create a high damageable variable. We can write object equals to the collider as collider dot game collider as the interface, or we can just get component this interface and then call in some function. It would be a lot expensive. Not expensive, but it would be a lot cheaper, easier, and reusable code. Since we now have just one of that, we can just have player normally. But if we were to have enemy create all of their scripts to use iDamageable, what it will do is that it will take the interface ports from that and give to us, and we can then reuse that to some function calling or reducing the health loss, stuff like that. And it is easily extensive because it not just works for player, not just works for enemy, but it works for all the objects that you have set in their scripts as iDamageable. If you inherit from any script as iDamageable, then you can create an instance of that script and then store that inside of that interface. In our case, it's iDamageable. We can modify its values. You can even have events inside of this, but we're not going to talk about that. We're going to talk about the main thing, and that's it for the main thing. You can even add functionality as usual to this, and if you have ever used the on pointer down, on pointer up functions provided by Unity in the event systems, then you may know that how strict are interfaces. If you have just implemented the interface, then you need to implement all the members of the interface, and we can even call the function of that interface like this. We call that, and in some cases we just do bulk function calling like that, and you can just go control click to where the actual function would define. You can even go to any of these variable types, data types to go where they were defined, as you can see. But don't try to read those because you're not gonna get anything. Literally anything, because I think it was written in C++ because most programs are written in that. Most of the utilities were written in C++, and you'd not be able to access any of those functions because CLR, or Common Language Runtime, I think that may not support the having those functions or those done. If we have iDamageable, there we go. You can just go and control click. When you press control, you get a line and this kind of a link select cursor. You can press that to go to that place. Like we have this, it's there. Get set like that, and that's it for today, guys. In a later video, we'll even learn about math in C#, exceptions, files, delegates, generics, and a lot of different stuff. Make sure to Like, share, subscribe our channel for more content like this. And I am AttiDude signing out.